Good afternoon. Welcome back. This is Bill Snyder with the Gustave Larson Company, and we're about to start on session 3, which is we're going to talk about application, system design, installation, system startup, and operation. We're going to cover that today, and then we'll have one more session after this that we'll finish up on. But this particular session is starting with application. So with that said, let's switch over to that, and we'll talk right now a little bit about application. Slide myself up out of your way, and I'm going to look at some applications for MNP. Now here's some examples here. Over here on the left, you'll see some wall hung units. You'll notice they're a little ways from the ceiling. Just keep in mind that the top of these units have is where the return area is coming in the top. And when you lift off the cover or you hang this on the wall, you put it on and then slide it down. And when you lift it off, you tip the cover up. You have to have enough room up there for all of that. Plus, you have to have room for the return air. The other thing to think about in this particular application is they put these above, in this case, it's like a doorway or a window. Bottom right-hand corner, and this can vary, we can do things differently, but in the bottom right-hand corner here, we have where your line set comes out. It goes straight out the wall through a 3-inch hole. Your line set, your electricity, and your condensate will typically go out the back of the wall, and then typically they go straight down because condensate water has to go downhill, and you put the condensing unit or the outdoor section right outside the wall here. But in this case, they must have gone out, taken a hard turn, and gone out somehow so that they came around this unit down the wall, or around this unit down here. Maybe they have their condensing unit sitting outside of this, what looks like a fireplace here. Not sure, but you have to do that, consider that. Also, you'll notice these are up high enough. This thing is got to be a 10-foot ceiling, I would guess, in this commercial application, because right above doors and windows, there is a header that gets put in there. And that's typically 2x10, 2x12, depends upon the span, but it's thick and tall, and probably not the best thing that you want to drill through, because that actually helps support the roof and so forth. So you, in a typical home, you'd have a window or door that's only like a foot from the ceiling, which is a header plate that you'd have to go through, and you'd probably have to mount this too close to the ceiling and you wouldn't get a good return. So you got to think about some of the applications. Now, in this case, this is a commercial building. There's a ceiling cassette mounted here in these actually panels up here are drop-in suspended ceiling. So that's really good application in there. It covers that area very, very well. Now, here's a case where probably will work, but it's really too close to that beam. Keep in mind, you are taking, if these are, and these don't look like 2x10s, these look like they're beams, so they're probably 3-4 inches thick, going across the very top of that return air. That's not really a good application. The thing should have been dropped down a little bit. Or even in here, that looks like a little vent or an exit sign, I'm not too sure. You could put above this wall here, you could possibly put a air handler, like the PEAD type air handler, and just blow it right out into the room. So I'm not sure this is the best application. It's kind of open around the beam, so it probably works, but I would not have done this. This is, to me, that's not that great of an application. So here's, let's look at something else here. Over here on the left is just an outside unit sitting up on a platform, because it's obviously a rooftop installation. If this was a heat pump, this is a very bad application, because when it goes into defrost, the water will hit this pan and freeze, and you will end up ruining the bottom of the unit and destroying the coil. But because it's got the wind baffles on it, I'm going to wager to guess that this is a cooling only unit that they require, like in this room here. This is a server type room. If this is the unit for this room's going to have cooling all year long. And so this is a cooling only unit, and they've got the wind baffles on it to get it down to -40. In that application, this is good because you're way up off the roof. Even though it's a cooling only unit and doesn't need to be on a stand, it needs to be elevated above the snow line because it's going to have to get airflow across here all year long. So deep snow up there, this would be a fairly good application. So I'm liking that. The server room, I kind of like where this is mounted here. Keep in mind, this has got the MHK1 thermostat, and that's the receiver for the thermostat there. So really nice application here. They can come in here and adjust this. I like where they mounted this. They've got the condensate, it looks like running probably out there. That's where your line set is running. It looks like this is just electrical on this side. So electricity went in this side. It looks like the condensate and all runs out this side. I am guessing they insulated the condensate because the condensate will be cold and could drip. And they don't want any dripping in this room at all. They mounted this above the door, so if it does drip, if the condensate paint plugs up or starts to come down here, it'll leave a puddle in front of the door and it won't be dripping on any electronic components. Good application. So a ceiling type cassette above this would probably not be the best application. You want to, if you're putting a ceiling cassette in, make sure it's like up here where if it does fail and does drip, it won't land on any components. Our ceiling cassettes do have some drain warnings and on the pump and so forth that if it does fail, it will shut off. But typically commercial applications, air handlers, you have a disaster pan by code underneath. Just depending upon the application, you might have to do something different. Now here, this is a ceiling cassette here that's mounted in what appears to be a sheetrock ceiling in a commercial establishment with all the exercise equipment underneath here. But you notice what this is. This is a trap door so that you go up and service this. Right above here, right in this section right here, or here, depends how this is mounted, you've got an electrical service panel, and this is just to get in there and service it. So pretty good application there. Now here's something that, this is an application where there's multiple rooms conditioned. This could be a motel. It might be a, well, it does say it's a motel. Could be an apartment complex, could be a motel. From that big chimney there, I'm guessing there's a big boiler or something in here doing the heat, and these are cooling only units. If this was a heating system, a heat pump system, and it went into defrost, this is open to the bottom unit here, and it would probably drop water and freeze up. This bottom unit would become a ball of ice. So if this is a heat pump, this is a very bad application. If it's a cooling only unit, I'm still not happy with this because the service for this unit is in the top here, and when you pull this top off, you have to get into this section here to do service. This right side and the top. So this could be tough to service in the future. So I'd be careful not stacking them on top of each other like this. If you do, make sure you leave enough room that you can get in and do the service. And here's an example of an MXZ multi-zone unit. We know that because here's the outdoor unit, and here's line hide going up to this unit here on the 3rd floor. there's a unit on the second floor, the main floor, and then there's a unit down here in the basement. So we've got at least 3 zones coming off of this unit. And this one obviously had to be mounted on a flat vertical wall. If you mounted it up here, the water would pour out of it from the drain pan. So that's probably the only application. This appears to be the back of the house, so this is mounted here. You probably don't want the line height running down the front of the house. Probably your only option is put that unit here, or you could put one of those low wall units down here. This could be a challenge to service and change the filter, being there's a stairway here. You have to put a ladder coming up here, or lay something across here to get up here and service it. So in this application, I don't know what else you'd use except for maybe one of those low wall units. Here's I think this is the final example of a system. This happens to look like a little house, little brick house. It's actually a library. Really good application for a library. It's capable of cooling a very large space. It's very, very quiet. This equipment is very quiet, and it takes out a lot of moisture. It helps keep the humidity down. And books and humidity don't really do very well. And the acids and all in your fingers turning pages and can react to the moisture, and it actually destroy the paper. So this would be a very, very good application. Now, I would say these are very quiet units, extremely quiet. I would recommend that you always have at least 16 foot of line if possible. Now, if you were in our training room, you're going to see our equipment's operating with probably 5 to 6 feet of tubing between the outdoor unit and the indoor unit. Extremely quiet. I don't hear any noise from them. But if you're going to mount this on a bedroom wall, say in the master bedroom, and the bed is underneath here and this unit's up here, I would be very cautious at telling them this is super quiet, you'll never hear it run, because it is a mechanical piece of equipment and it can pick up and have some noises. You've got an LED that can be basically squirting liquid refrigerant in there and having it evaporate. You can hear gurgling sounds from time to time. It goes through defrost. The switchover valve can change. So if you put it in the bedroom and you put it above the master bed and you have a 6 foot of line going to the outdoor unit, they probably will hear something. So I would recommend getting at least 16 feet minimum line length. That helps on the noise issue. And always be careful and choose your words correctly or wisely, because if you tell somebody that they'll never hear it, trust me, on the 2-3 o'clock a.m. day that they can't sleep, they will hear something and they will blame their lack of sleep on our equipment. And you'll be out there trying to figure out what it is. So just be very careful with what you say and claims that you make. We all know this is extremely quiet equipment. Okay, let's go a little bit into, we'll talk about system design here. Okay, when we're laying out a system, we should always determine the heating and cooling requirements and do a heat loss on the space. This particular space looks like it's 11 by, I don't know, add this up, 10, 11. It looks narrower than wide, but this is saying it's 11. So let's just say it's 11 by 11. An 11 by 11 space will probably take less, it'd probably be about 3,000 BTUs to cool it. Just a quick rough estimate. And I've had spaces like this where people put 1-ton units in there, 12,000 BTUs, and they say, well, it's a system that'll ramp down. Well, it'll only ramp down to about 30% of its capacity, which is still probably over capacity. So it'll come on and off and on and off. A 6,000 or a 9,000 BTU unit is probably possibly even oversized for most systems. So just be careful you don't oversize the system. It's really critical that we size this correctly, especially on the MXZs, because when one unit's running and heating, a little liquid will trickle into the other units, and we don't want to be overshooting the temperature. So very, very important that the unit be sized correctly. You get longer run times, remove more humidity. So that's a real plus. Also consider the airflow, how far you have to push this. 11 feet, I think any of our equipment will handle this type of room without a problem. But if you get into a big great room or something, maybe the little wall unit isn't the correct thing to cool the whole space, or maybe you have to put 2 in there. Maybe you have to use a ceiling suspended unit and push that air across the whole room. So the maximum air throws for the units you can find that data in our little service guide that we have available to you at no charge. So it's a little service booklet, and all those airflows are in there. They're also listed in the submittal data that you can get from MyLink Drive. All that would be for free. Air coverage, this is out of the little service guide that I talked about. And this is showing the airflow on the units with a wet and a dry coil. So in the winter, when that's in the heat mode, it will throw this many CFM, an average of a coverage 29.5 feet. That same unit in the summer, when that coil is wet and dripping with water, will only throw the air about 21 feet. So you lost a little bit of throw on a wet coil. So it's just something to consider. Most cases, the rooms are small enough, they're less than 21 feet, not a big issue. But if you're getting into a big, like a great room or commercial application where you want to make sure you move enough air, you want to take a look at a chart like this and determine it. These charts can be found in the service guide. They can verify if the equipment is performing correctly. They are not charging charts. In order to use these charts, you need to put the unit in the test mode, because in the test mode, it basically is running at like 60 hertz, and the fan should go to high speed, the compressor will go to 1 speed, and all these tables then will tend to work. And you can see if it is operating or performing correctly by looking at the outdoor ambient temperature and the condensing pressure temperatures, and can determine here on this chart, it's set between 70 and 86 degrees, depending on what line it is. But if you're at 325 pounds of pressure and it's 85 degrees outside, that system is working pretty darn good. And then also on outdoor ambient, looking at the suction pressure, same thing. If the outdoor ambient is, say, 85 degrees and the indoor air temperature is 75 degrees, we would be looking somewhere between 130 and 150 pounds of suction pressure. So these charts will just tell you if it's in the right ballpark. If you're not in this ballpark, the best thing to do is to recover the refrigerant, shut the system down, recover the refrigerant, and weigh it. If you don't have enough refrigerant in the system, then we got to go back to square one and do a pressure check and a vacuum and make sure this system isn't leaking, or you have to find the leak and correct it. So these are not charging charts. The best way to charge a system is to weigh in the charge. These are just to tell you if the system is working as expected properly. Consider the distances between the outdoor and the indoor unit. Like I said before, it's recommended that you have 16-foot minimum. We certainly can operate less than that, but they might hear some noises from the outdoor unit the closer the line set is to the indoor head. Always be careful if you're going to mount a system on an outdoor unit on a wall. Make sure that it's not a wall up against like the master bedroom or a bedroom. Try to make it up against a closet or some other area that if there is noise transfer from the outdoor unit, because there is a moving compressor with moving parts in it and a fan moving, and there's reversing valves and things that can happen. You want that any noise transfer to go to a space that isn't going to wake somebody up in the middle of the night. But the piping lengths, the standard length that you can do on these M series is typically around 25 feet. If you go over 25 feet, you got to look at the chart and see how far you can go. And on these top units over here, these units, you have a maximum of 65 feet you can run a line. That's still quite a long distance. But if you go 65 feet, then you have to take that times 0.878 to determine a correction capacity of the equipment, because it will be a diminished capacity because you have some line loss. So let's take this 18,000 for example. If we take the 18,000 and you look that particular model up in the catalog, there's a newer model that's a -2 or whatever. It's actually rated 18 now, but this particular model number in the catalog, that 18 is 18,000 BTU nominal capacity, which actually in the book, the rated capacity was 17,200. If you needed 18, you'd be short already. If you installed that with 65-foot of line set and you take that BTU times the correction factor of 0.878, you end up with 15,102 BTUs. If you needed 17 or 18,000 BTUs on this system, you will come up short on the hottest day of the year. It'll work fine some of the year, but if your design conditions are say 95, on that 95-degree day, not going to handle it. You're going to get a phone call. So you should be aware of this. If you install them with the short line lengths, you pretty much stick with the rated capacities. Things that we do and don't do, we do not ever recommend exceeding the line length limits that are listed in the installer's guide. They're also in the submittal data, the line lengths, and the vertical lift or vertical separation between the indoor and the outdoor units are listed in there. So the length and the vertical separation is important. We don't install sight glasses because we do not have a true liquid line. If we install the sight glass, you would always see bubbles in there. Even if you drastically overcharged it, there'd always see bubbles in there. So a sight glass will do you no good in this application. So don't put a sight glass on, and don't install filter dryers on new installations. So we have, if you install it properly, and we'll go over those procedures momentarily, but if you install it properly, you shouldn't have an issue with the need of a filter dryer. If you had a burnout, which I don't know that I've ever seen a burnout on one of these, but if you had a burnout on one of these, you would probably take a filter and say in the air conditioning mode, put it in the what we would look like a liquid and a suction line. As long as you knew the direction of the flow of the refrigerant, put it in there and try to clean the system up for, you know, an hour, and then change it again, and then go and let it run for maybe a week, and then change it again, and then actually remove it. I would not recommend leaving a filter dryer in our system. Install P-traps. We never do that because that's a pressure trap, and that will get oil. It'll become an oil trap. It'll end up full of oil, and that's when our systems ramp up to full speed. It'll suck that oil out, and you'll get a liquid oil hitting the compressor as a slug, and that would not be good. Piping sizes. Typically, this is where I was talking about the maybe having to use the fittings, but typically the units are 1/4 and 3/8. There's some that are 1/4 and half, 3/8 and 5/8. It's always driven and dictated from whatever the indoor head is, not what's on the outdoor unit. So if the indoor head is 1/4 and 3/8, you run 1/4 and 3/8 all the way to the outdoor unit. And these are the MXZ multi-zone units. Just for an example, the 2C20 has got 2 lines. Both are A and B port are 1/4, and A and B port gas are 3/8. When you get down to this 24, there is 3 ports. That's a 3C30, so there'd be 3 ports, and the liquid line would be 1/4 inch, and the gas or suction line, the gas line would be, port A would be half, so it'd be 1/4 by half, and port B and C would be 1/4 by 3/8, and so on and so forth. So if you had 3 smaller heads that were all 1/4 by 3/8, you would have to take a fitting at the outdoor unit and reduce it down. And these are the fittings you would use to do that. And you can also find on the submittal data under accessories, you can see the fittings listed right there as your port adapters. Okay, maximum pipe length requirements. Let me move this thing over here. I don't know why I moved it, but maximum pipe length requirements are typically around 65 feet maximum for M series, with a 35 to 40 degree or feet differential. And some of these M series down at the bottom, these are all find this all in the submittal data or in the installer guide. There's 100 feet with a 50 foot of separation, vertical separation. Then in the P series, you'll see the minimum pipe length is 165 on these, 225 on these, and 245 on these HA30s. These are hyperheat models. The HA30s, 36, 42 will go out to 245 feet. That's a phenomenal distance. I don't know of anybody else's product that will do that. So just be aware of that. And the number of bends, I don't typically consider a bend. If you take the refrigerant and bend it, a pipe like this, I don't consider that an elbow. It's, as long as it's very, very long radius bend, it's fine. If you're going to braze in short or long radius elbows, never use short radius, but long radius elbows, then not only do we braze with nitrogen, but we would then start counting the elbows that you put in, a number of bends. Maximum pipe length on the MXZ. This gets a little tricky, a little difficult to do. So we'll show you kind of an interesting or a good way to do this. The maximum pipe length on that 2C20 is 164 feet, 49 foot of vertical separation, and each branch length can't be over 82 feet. That's true on all of this equipment. None of our branch lengths can exceed 82 feet. Still a nice long distance. But on these units with the branch box here, these can go 492 feet total. If you add up all the zones and don't go over 82 feet, you can have a total pipe length of 492 feet with 164 feet of total differential separation. And these are branch boxes again, 142 feet or 192 feet and 164 vertical feet, but no branch length can come over 82 feet. And basically, I like to think of this as an eye chart. This is your outdoor unit, and you got 2 branch boxes on this unit. So you're actually measuring the distance to this T and all the way to the first branch box and to the second branch box, and then you're adding up each line length between all of the units and adding them up, and you cannot exceed the limits. There's a real easy way to figure this. And then you also, once you do this, you have to figure out how much refrigerant to add, because anytime you are adding a unit with a branch box in, you are going to add refrigerant. You can do all of this on a program we call Diamond System Builder. It makes this very, very easy. It'll tell you, first of all, if the indoor and the outdoor units are compatible. It'll tell you if you've oversized it, undersized it, what the refrigerant calculations will be. Diamond System Builder is a free program that you can download from mylinkdrive.com. And you literally, on this side, you drag stuff across and drop it on here. So you pick your outdoor unit, you pick all your indoor equipment, and it tells you the line sizes, like 1/4 and 3/8, 1/4 3/8, 1/4 3/8 here. And it tells you its capacity based on, when you first set this up, you pick your area. Like I'm in Minneapolis, so I pick Minneapolis, but there's all major cities around the country are in there. Pick the closest one to you, and it will tell you the rated capacity based on your design conditions. Ours is like -19 here, so we get less heat out of the unit due to our design conditions than you would if you were installing this same in Phoenix, Arizona. After you do all this, right down in here, it says additional refrigerant required. This is a 1-to-1 unit, so there's no additional refrigeration required. But if this was a branch box unit, it would require additional refrigeration. So it's kind of neat. It does a system design, component layout, does a BTU calculation, refrigerant charge calculation. You can save this, print this out, send it to the job site as a PDF document. It'll give you a bill of materials if you have added controls, like on this unit here, would require a some sort of a thermostatic control on it. This unit would come with handheld remotes, but this unit would not. And it'll, when you go to save or print this, it'll tell you that you haven't picked a control. So kind of gives you a heads up, which is kind of neat. Okay, we're going to go into some installation of it. Here he's mounting the plate on the wall, and you notice how far from the ceiling he is. He's a little ways from the ceiling. Not sure what that hole in the ceiling is there, but this looks like a good installation. Common pitfalls: incorrect wiring, huge problem. This is showing some wire nuts in here, and it's showing some sort of a switch. What we do is we take our wire from S1, S2, S3 on the outdoor unit and go directly to S1, S2, S3 to the indoor unit. We cannot have any joints, splices, switches in place. Now, if a switch is required for a disconnect type switch in there, Mitsubishi does sell a switch. Looks just like a common household wall switch, light switch, that you just switch on and off, use a standard plate. But the switch itself is a true 3-pole, separated each pole, so that no communication problems will occur. And that is available. What we typically do is all of the indoor units are powered from the outdoor unit. So when you throw the disconnect on the outdoor unit, everything downstream of it is off. And that's usually acceptable in most areas. Some areas, your electrician may require a disconnect at the indoor unit. And then in that case, you would use the approved Mitsubishi disconnect, not something like this. Real important to insulate both lines. They should be sealed properly so that there's no dripping, line loss, that they both be installed with both insulated, both typically strapped together. That would be the way we do it. Leaks due to improper flares. This flare is actually cut in half, so you can kind of see what the flare looks like. But I would look for what they're showing here is some oil. If you ever see oil around a fitting, then you probably got a leak, because a little bit of refrigerant oil will leak out with the refrigerant itself and typically will leave a stain of some sort. That's a good way to find your leaks. A proper flaring tool is highly important. Don't use your old Imperial Eastman that you got 20, 30, 40 years ago. Use a good quality R410 flaring tool that rolls out the flare. Don't use the ones you put on a drill bit. They're not good. They don't do a really good flare. They may work fine for low pressure air systems, or maybe even an old oil burner or something like that. But when you're talking of R410, you need to have a very, very good quality flare. If you put a good flare on there and you torque it per specs, you will not have a leak like this. So that's a problem. Improper condensate drain, improper suction line. If this line comes in and wraps around in here, you can create a oil trap in your line. So just take your line down and in directly to the outdoor unit. You're going to cut it and flare it. There's no need to put loops in the line. You don't want to do that. You want to drain the condensate properly someplace. This is above looks like above a garage, and they're draining the condensate right on the roof, which will probably go down and go into a gutter someplace. I would probably take this and run some PVC along the wall and go into the gutter, because this thing dripping on the roof is going to leave a stain or create some sort of algae growth that will not be good, and you'll be back with a complaint. So make sure it's good installation. Again, I mentioned that we use nitrogen. You use nitrogen if you have to braze. Typically we're flare nuts, we don't have to braze. This was brazed without nitrogen, just with some oxygen in the tubing, and you get this black, crusty oxidation. When you start the system up, the refrigerant and oil is a great cleaner. It'll tend to clean this off, and all this crud will go down the system and find one of those 100 mesh screens, or it'll find the cap tubes. There's some cap tubes in the system, and there's also the LED, linear expansion valve. There's all places for that black stuff to go. It'll find a place, plug up. Now you got a real problem trying to find it. Where those 100 mesh strainers are, they're a strainer that is pressure fit inside the pipe, so you can't see any dimple, can't see any place that it actually is. If it plugs up, you'll probably find, if you follow the tubing along, you'll find a little area that's frosting up in the tubing because there's a restriction there, or you can physically feel a temperature difference. You would have to cut that out and find a strainer and try to fit it in there, which in this equipment, there's not a lot of room to work, so that could be a problem. So if you have good installation practices and use nitrogen, you'll have a nice shiny fitting like this. You won't have an issue. Also, in our climates, we're in a cold climate, this unit should be elevated. If it's a cooling only unit in like a server room, you want to elevate it just to get it above the snow line. If it's a heat pump, when it goes into defrost, this will ice up and it'll break the unit and or just fill up with snow and not work. So just those are common problems. We're going to go through a step-by-step installation process next, starting off with selecting locations and locations of the equipment and in air circulation and throw. This is a big grate room, for instance. They're suggesting maybe 2 ceiling type units in this grate room, or if you put one unit like on this wall, but it looks like there's 3 glass doors. If this is a vaulted ceiling, maybe you could put a big unit above and blow across here. But this is a long distance, so you probably only blow about halfway across the room and maybe not hit over here. Maybe you put a couple units on this wall blowing this way. So you just have to consider that. And then when you consider it, where are you going to run your line sets? If you're on this wall, you can come out the outside wall, maybe put a condensing unit like right here. These 2 units would go towards that condensing unit multi-zone, and this unit would go to that multi-zone. And then on the other side, you might want to put a different one if you can't, if there's no way to run your line sets. You might go up and across the attic and down. And there's all sorts of things to consider of where you're going to install this and how you're going to get your line sets there. This was a one-to-one. This is a kitchen area. And maybe you could put a ceiling cassette in here, probably not. You're probably talking about putting the wall unit in here. This dotted line represents a soffit above the kitchen cabinet, so you probably can't put it on these walls. Looks like a refrigerator and all over here in the hallway out here, so you probably can't put it there. You could probably put it here or here. If it's a one-to-one and you put it here, that would mean that your condensing unit would end up right by the entry, right by that door. Probably not the best thing to guess with, a condensing unit by the front door. So I'm probably going to put it over here. And the master bedroom, kids' bedrooms or guest bedroom. Now, here's where I would say, my own personal opinion, if they're having trouble deciding how many units to put in or where to put them, if your kitchen is comfortable and wherever your TV is comfortable and the master bedroom is comfortable, you're going to have a happy homeowner. There will be some air that drifts down the hallway here and goes into these other rooms, and they may not be as comfortable, but if you put a unit here, here, and here, you're probably going to have a happy homeowner. The kids will just get what they get. When the kids are tired, they'll end up sleeping anyway. So if they want to put them there, great. But if they're saying, I can't afford that, I only want to put three heads in, I would pick the master bedroom, wherever the TV is, wherever they spend the most time. Maybe it's an exercise room, but wherever they spend the most time, and the kitchen, because that's where people, when they come home from work, they end up in the kitchen. When people come over and visit, a lot of times you end up in the kitchen. So you want to make sure the kitchen is comfortable. Plus, kitchen has an oven, microwave, heat sources in there to heat up. You want to try to cool that down. Installation of the outdoor units. You need to have space. There's a chart like this in every unit. This is just happens to be one of the outdoor units, but they're saying it has to be 4 inches or more from the outside or from the wall. In the back, the coil is across the back side here, so you have to be able to get in there and clean the coil. They say you can do it in 4 inches. This side and the top is where the controls are. The control is sitting right in here and on this side. So it says 14 inches or more. 14 inches, can you squeeze in there as a service guy and actually work in a 14-inch space? I'm not that big. I don't think 14 inches is enough. So just consider leaving enough space. This side, not as critical, although there are some screws on this back side you'll have to get to. So you have to, if you need to take this whole outside skin off. So make sure you leave enough room to service this thing because it is got a fan in there. That coil is going to get dirty. You're going to have to clean it eventually. So, and if you have to do any service on the board or compressors in the front here, you have to be able to have enough room to get in there. The clearances are very small. You can put these in a very tight area, but again, you got to be able to work on it. They're showing this up on blocks. This might be fine in Phoenix, Arizona or someplace to put it up on a block like this. Not in our market. That's not high enough, and the water will hit that block and start to freeze, and you'll have problems. So you want to make sure this is on a stand that it's plenty of room underneath it to drain, and obviously have service access. This is the wall plate on the indoor wall units. Kind of looks like this. In the class, I actually have them. I can show you how this works probably better, but I'll try to explain it here. On here, there's all kinds of neat information. It's kind of a sheet metal thing. If you're mounting this on a flat wall, make sure the wall is flat and level. Sometimes walls bow. If there's a stud in the middle here and you tighten it here and here, there's going to be a bow to this plastic. When you clip this wall head over here, it's going to go on really tight, And then when this unit heats up and cools down, or the sun heats up and cools down the outside wall, you could get some ticking sounds as it expands and contracts on here. So if it's going to bow like that, if you tighten this down and this side's sitting at half an inch, 3/4 of an inch from the wall, and you have to push it in place, loosen this up and put shims under either side so that it does not bow. Otherwise, you could get some ticking sounds, and then, of course, that will wake somebody up and you'll get a phone call. But on here, there is some little slots that kind of stick out a little ways. There's slots here, here, and right here. Those slots, and it's printed right on the board here. It may be in millimeters, maybe in inches. Sometimes there's a sticker on here that converts it to inches. But this is telling you how far from this slot you can put your tape measure into that slot and pull your tape measure across, and it'll tell you how far to the center of this 3-inch hole to drill for your line set. So that determines where your line set's going to go. There's another slot on this side, because you can have the line set come out here. You can have the line set come down, out the bottom, out the side, out this bottom. You can go out the back. There's different ways you can do it, but in here, this is the typical way: is the line set's laying in here. You bend the line set out and shove it through the wall, right through that hole. This is a knockout here. This knockout here can be used for a number of things. We have if it's new construction, there's a rough-in box that can mount on the wall that mounts right behind this knockout, and your line sets will come through there. Comes through here through this little rough-in box. I've even seen people knock that out if this is going to be mounted on an inside wall, and put a little block in there and put a condensate pump back there or something. But you have to service it, so just keep that in mind. So that is used for that. There's a little, there's even a line that runs down the center here that if you hang this on a hook, you can use it as a plumb bob to level it, or you have these knockouts here to put a level. Put a longer level on this one or a short level on these two. The level actually literally sits down on it because these things are bumped out. These little marks here look better on the plate than they do on this diagram, but these indicate a flare nut. When the line set is in the back of this unit, it comes out this corner and it's laying back across the back of this unit. Now, typically you bend them out and right through this side, shove them through the wall. But you don't have to. You can come out this side over here as well. These two flares on here tell you where that line set, when you hang this on the wall, those lines are going to be right there at that spacing. So if you're bringing a line set from outside through this way, back through the wall, through the side, through the bottom, you can make your flare right here and here. And then when you hang this unit on, everything will line up. So you're not trying to hang the unit out of the way, make your flares, see if they line up, put it back. This will be the exact same spot. You can take the styrofoam that comes as a shipping thing on each end and hang this on and shove that underneath to hold it away from the wall so you can get in there and make your flare. Or there's also some a device that we have that hangs on the bottom here, and then you can sit this on it and work on it as well. But there's a lot of information on here. It'll tell you how far from this mark up to the ceiling to go. In this case, it says the minimum height between the edge here and the ceiling is 3 5/8 or more, and 5 11/16 or more from the left side, and it'll tell you in here 5 1/4 from the right. They're saying from the wall here to the edge of this is 5 1/4, because this is going to overhang, and you can actually mount it up against the wall. But let me warn you, all of the electronics are in this side, And if you have to do the service, you have to pull this off and get into the side. So I would never mount this thing 5 inches away from a wall. That's just not enough room to do service. So you just have to consider that. And when you drill this hole, make sure it's slightly downhill and seal it up real good. We actually have a wall sleeve that we sell that goes in there to seal that up. But seal it up real good. I've actually seen mice come up the tubing and the wire and crawl in and make a nice little home in here all winter long. And homeowners don't like that. They don't like the fact that mice come up in there. So make sure that's sealed very well. Also in the summer, if this is open, hot, humid air can come in through the back, actually get sucked in through the fan here into here, and then you get humidity issues here, and you can it can form organic growth. I say organic growth. We never say the word mold to a homeowner. It's organic growth or some sort of buildup in there. If you say it's mold, you're going to have some homeowners will go, can you clean it? And some will freak out because mold scares a lot of people. So just be very careful what you don't. Okay, here is one of the ceiling units. This particular unit here hangs down. It has a condensate lift mechanism right here. And this is your service panel. So you have to be able to get to this section here. And this has, if you're going to mount this above the ceiling, you have to have an access door to be able to get to this. So just be aware of that. And these units come upside down in the box. These little fingers here to hang it on that they're showing here in red circles, these actually point down when you're hanging this. I've gotten phone calls and done this myself where you lift out of the box, lift it straight up and hang it, and find out later that it's upside down. So you just be very careful of that. The wall unit, this is a floor mounted, it says, but it's actually a low wall unit. This thing here mounts on the wall, and this unit hangs on it, and this is where your piping comes out. You don't want to drill into the sill plate. You have to have it up high enough. So as long as you're up, typically above your woodwork along the bottom or your mop board, then you should be okay on this particular unit. And this is the ceiling suspended unit. This has the ability of bringing some outside air in. This mounts up against the outside wall. Your tubing all goes straight out the back, and it mounts up against the ceiling. Caution you on this one and the last unit we looked at, these don't just get anchored with sheetrock anchor screws or anchor bolts. This has to go actually up above the ceiling and hit something solid, because these will pull out of sheetrock. I actually saw this particular model hanging from those that you put in. They spread in the sheetrock. They thought it would hang it. It didn't do it. David Philibert, the guy I worked with, went out with one that was hanging off of a wall that way, and the complaint was it wasn't draining properly. It was leaking condensation. He got there, and the top left-hand corner was just hanging away, and it was enough to just tilt that unit enough that it didn't drain. So ceiling suspended units, same thing. You want to make sure these are anchored really well. This particular unit is a P series. We have out the side, both sides, you can run a little duct into a separate room to get a little air movement into another room. And in the corner over here, we can bring in some fresh air. This also has a lift mechanism that lifts the water up and out. And it comes with this little gauge. So when you take it out of the box, the top of the box is a template. So you can hold the template up to run all your threaded rod down through the template, this little cardboard thing. So one guy can do that all by himself. Then you can lift it up and slide it over these brackets and hold it in place. And then you can lower the bracket down to this little cardboard gauge. Then this thing will snap right into place. So this technically could be installed by one person. climbing up on a ladder with one of these. I'd personally rather have two people help me put it in place, but once it's in place, one guy can do all the adjusting by himself. On that unit, there's 4 vents coming out the side, the louvers. You can unplug the vane motor and shut off a couple of those. You have to have at least 2 running, but you can have one shut off so it's not blowing on somebody, or this situation here where you have it blowing down, say, 2 ways, like in a long room, hallway type thing. You could do something like that. The indoor multi-poised air handler can be horizontal left, horizontal right, upflow, or downflow. If you're going downflow, you remove the coil, flip the unit over, and put the coil back in. If it's above a ceiling or a horizontal application, it's required that you put an auxiliary drain pan under it. The indoor branch boxes allow for you to mount it up against the ceiling like that, but again, there are components in here that may need service, so you have to have some way of getting to it and have to have a minimum clearance underneath, because you have to pull that pan off to get to it. It is a multi-position, not 100% all position. It could be mounted flat on the ground like this. It could be mounted hanging suspended from a ceiling or a bracket like this. It could be mounted on the wall like this. If it's mounted on the wall, the tubing has to be face down, otherwise this becomes a big oil trap. If you want to mount it on this wall with these facing this way, it's fine. If you wanted to mount it on this wall with it facing this way, all you would have to do is take the top and the bottom off and reverse the pans, and it would go, you can mount it the opposite direction, but those pipes have to be facing down. Unit has to be anchored down solid. These are very thin units and tall. They could blow over. So there is anchor bolts, and has to be above the annual snow line. If they're cooling, they're going to be cooling in all winter long, or if they're a heat pump, they have to be on a platform as mentioned. Interconnecting the wiring, on a typical outdoor unit, you have your L1 and L2 coming in from the disconnect, and you have a ground. Then you leave here with an S1, S2, and S3 on the outdoor unit here, and you go to the indoor unit. Make sure it's grounded. Both lines have to be grounded. And you follow electrical code. Now here is what the indoor unit looks like, S1, S2, S3. There's a channel that you can push this wire in. It pops up here and connects here. Use the appropriate size wire. Some of our units use 14.3 with a ground. Some use 16.3 with a ground. So make sure you use the proper sizes. It says here M series 14, P series 16, not true anymore. So just be aware of that. The new P series that end in 7 that can cool down to -40 actually use 14 gauge wire, and the M series MXZ multi-zone units actually use 16 gauge wire. So just follow the installation manual just to make sure. I would recommend stranded wire, because in here it's a little tight. It's easier to work with stranded wire. Stranded wire squishes down, get a better connection on it. Just works so much better. Here's the outdoor unit. You've got your L1, L2 and ground, and your S1, S2, S3 on the outdoor unit. Go to S1, S2, S3 on the indoor unit. How does that work? S1 and S2, if you check your voltage between S1 and S2, you're going to get 208, 230. You should read the same thing you're reading here as you do over here on L1, L2. But between S2 and S3, S3 is our communication, and that's a DC signal that modulates. It kind of bounces all over the place if it's talking. So S2 is used as our common for our DC signal, and it's used for 208, 230 between S1 and S2. Okay, so the wiring, the The typical M series 1-to-1 unit is 14 gauge wire. You've got 16-3 ground wire. If it ends in a 6 or 7, then it goes to a 14 gauge wire. But otherwise, if it doesn't end in a 6 or 7, it is a 16 gauge wire. And on the branch boxes, you've got 14 gauge. These are the ported type. And if you go with the branch box type, you go 16-3 between the indoor heads and the branch box. You got 14 gauge wire between the branch box and the outdoor unit. And you have a 16-2 twisted shielded communication wire that runs between the outdoor unit and the branch box. This is the preferred method of wiring it. You can power the branch box separately with its own power instead of pulling it from the outdoor unit. That will require a separate disconnect. Also, when you start the system up, you have to power up the indoor systems first, then go out and power up the outdoor system. If you do that in the opposite sequence, it will not run. Okay, interconnecting the systems. Just make sure that this S terminal is grounded. This is the 16 gauge twisted shielded pair from the branch box to the outdoor unit. This is this side, M1 and M2 on this side is for communication cable to the branch box. On this side, this is M1, M2, and the shield is for a central control panel. If you're not using a central control panel, you're probably never going to use this. This wire here has to be grounded. In the installation manual that comes in it, in the equipment, there's a plastic bag with the installation manual in it. There's also a black wire with a 1/4 inch spade terminal that gets plugged on here and then run over to the shield or the grounded ground terminal on the unit. It doesn't come on the unit because if you're using a central controller, you can link many of these systems together and run them off of one central controller. Then you only ground the last unit. Otherwise, you daisy chained everything. If you are installing a condensate pump and it has a normally closed switch that if the drain pan starts to overflow, the switch opens and shuts down power to the unit. The way we do it is we break S1. So S1, S2, and S3 normally go between indoor and outdoor unit. In this case, we're taking S1 through the common terminal back through the normally closed terminal to the outdoor unit or to the indoor unit. And if it opens, it will shut down the equipment. That's one way. On all of our P series systems, I believe now have a CN4F connector switch, which is a float switch inside the system. A lot of them have float switches in them. But if you want to put an auxiliary drain pan in or an auxiliary switch, you would cut this jumper and then you would wire your switch to that. Also, we have on some pumps you break TH2 thermistor, and this style pump and this style pump comes with these all these little adapters. You unplug the TH2 thermistor, you plug this wire and harness into it, and you plug the thermistor into the wiring harness, and then the other end of the wiring harness into this pump. And that way, if this sensor here senses water, it will shut the equipment off, and you get an error code. Interconnecting the drain systems here, this is a proper thing. You're going downhill, you're sloping downhill. If you go uphill, you're going to leak condensate on the inside. If you use a vinyl tubing that is rolling along like a ceiling or something, you're creating traps in there, you could get a leak. So if you're running a line like across an attic or something, use hard PVC so it doesn't do this. If you're going into a floor drain, strap it to the top of the drain so that it does not stick into the water, because that would be a problem. And if you have multiple units, you can run them all into a common drain. So that will work fine. It kind of excludes the one air handler is that we do have a trap on, the big air handler, big green air handler, because that's like a positive pressure blow through coil. So that you could trap just like you would a normal furnace that you're doing today. What this chart is showing here is when you're reading these units, as condensate lift mechanisms, they lift the water up out of the pan here and sling it out the top of this unit. It may say you've got like 21 inches. That is from the bottom or the top of your ceiling up. So if this unit's already 12 inches or 10 inches tall, you're only going to be able to go another 8-10 inches of height, and you use whatever size pipe comes out of here. I think it's 1.25 inches, has to go up to this point, then you can go into a standard drain fitting from here on out. So just be careful with that. Some people say, well, it says I can go 33 inches, so I went from there up 33 inches. Won't work. So just be aware of that. This again is talking about putting a proper flare, using a good quality flare nut, and torquing the unit to the proper foot-pounds or Newton meters or kilogram force centimeter is what this is. It doesn't really make any difference. The charts will show all three. So if you buy yourself a good torque wrench and it happens, you get it home and it happens to show that it's Newton meters, not a problem. This is your conversion on here. Don't use this chart as gospel. Use the one that comes with the equipment, because some of the torque is different on some of the equipment than others. Even though it's a 1/4 inch or 3/8, the torque is can be different from one piece of equipment to the next. And the reason we want you to torque it is not so that you get it tight enough, is we don't want you to over tighten it. If you over tighten the flare, you can actually crack or flatten out the flare and actually do more damage. So 1/4 inch fitting doesn't take that much torque. The new R410 angle for a flare is 45 degrees. It supposedly was different in the old days. I don't understand it, because to me the fittings themselves never changed. But there's definitely a difference in the new flaring tools out within the last, well, since R410 hit the market. They recommend that you put a little drop of oil on the inside and the outside of the flare, a little bit on the fitting. I also like to put some on a little bit on the thread, so when you're torquing it down, you're not getting that as it's tightening down. Then it actually is a nice smooth tightening action until you hear the wrench click. What kind of oil do you use? Ideally, refrigerant oil would be perfect. But I have some guys that use vacuum pump oil, because they always have vacuum pump oil with them. You're not putting the oil in the tubing. You're just putting a little bit on your finger and putting it on this fitting, just so you have a good seal. So some guys use vacuum pump oil. We talked about this. Make sure you trickle nitrogen through the system if you're going to use a torch. Use good quality line sets with both lines insulated. And we buy line sets. Some of them we buy Diamondback line sets from Mitsubishi. Some we go out and shop and find the best price for you on line sets from people like Mueller and companies like that. So if you buy a line set for a mini split from us, both lines will be insulated. Some of the line sets come with flare nuts on them, some do not. If you buy the very long, like 165-foot line lengths and cut your own, obviously they don't come with flare nuts. If you buy them even with flare nuts, I recommend cutting them off and reflaring them, because this could get hit and banged around and shipped up. And cut them off, reflare them, get a good flare, and use the flare nuts that come on the Mitsubishi equipment, because there's flare nuts on all the indoor and the outdoor product. When evacuating and pressurizing the system, we recommend that you pressurize the system to 600 pounds PSI with nitrogen and hold it ideally for, this is best practices now, ideally for 24 hours. We know that's not always possible, but if you do all your line sets first before you do all your wiring and everything else, then put the pressure test on there, go to lunch, come back, look at the pressures. If nothing's changed, you're probably pretty reasonable that it did not leak. You say, why 600 pounds? Our relief pressure valves on our units are just about 700 pounds. So you're not going to blow any relief or anything. 600 pounds is good. If it doesn't leak at 600 pounds, it won't leak under normal applications. To ensure a good dry system, we recommend you use a triple evacuation where you evacuate once. Now you've already pressure tested with nitrogen. You take the nitrogen down to 0, you pull your vacuum down to 4,000 microns. You break that with some nitrogen again, pull it down to 1,500 microns, break it with nitrogen again, and then go down to 500. It's very, very fast. Sounds like more work because you're doing a triple evacuation, but if you're doing it this way, it's actually a faster, quicker evacuation, because every time you break it with nitrogen, you help to get rid of any moisture in the system. So it should be faster. Plus, most of our systems, you're using 16-foot of line and 1/4 and 3/8 lines. So you can usually pull a pretty quick vacuum, and you conduct a rise. And if it doesn't rise, then you should be good to go. Charge test and run. Piping lengths up to 25 feet. You don't have to add any charge on these M series units. If you go over that, you have to add, in this particular model, you have to look at the installation manual, but in this particular model, you add 1.8 ounces for each 5 feet. And down here on this PUZ, for example, we talked about that 18,000 unit. That you can go up to 100 feet. It's pre-charged, ready to go up to 70 feet. So when we talked about that earlier, if you just would sell one of these P series instead of the M series, you don't have to derate it. You should be fine here, because you're okay up to 70 feet. If you go out to 100 feet with that, you have to add 6 ounces. So just follow the chart that comes with the install manual. Let's talk a little bit about jumpers and dip switch settings and operation of the system. Our systems have dip switches. They could be for setting addresses. Our systems already come auto restart, but if you're in a situation where they don't want the unit to auto restart, some military bases, they don't. They want to manually restart it. You can throw some dip switches and make sure it doesn't restart. You can have preheat control, defrost, finish temperature can change. Typical market we don't have to do that. Up along Lake Superior on the southeast side of the lake, they get the lake effect where it's very, very humid. Up there, they typically will set it to defrost at a higher temperature. You got a test run on the P series. I'll talk about test run on the M series in a little bit. You can force a defrost by throwing dip switches. So if you come out to a unit that's all frosted up, we can throw a dip switch and get it to defrost. And you have model and capacity settings. What that means is you may have a M or P series unit that is a 12,000 BTU. When you order a new board for it, if the board is bad, that same board may work on 9,000, 12,000, all the way up to 36,000 BTUs or something. And the same board works on everything, but they function differently based on how the dip switches are set. So you would set those dip switches for the right capacity. You can use a book to determine that, or just look at the old board and make sure that all the dip switches on the new board would be set the same. We also have some jumpers here that can be cut in certain applications. The only time I've ever cut a jumper, in some applications, we want a thermal fan off. The consumer complains that in the winter, the fan is running all the time because we're sensing return air temperature, but they don't want that. They don't like that. If you put an external sensor on, like a thermostat on the wall, it's going to sense the temperature like an MHK2, then we would typically sense the temperature at the control and we would do a thermal fan off. Now the MHK2 on most units, we can just set the thermal fan off from the menu. But on some units, you have to go in here and actually cut a jumper. And there's two different jumpers. One's for thermal fan off for cooling, one's for thermal fan off for heat. On the branch boxes, when you're installing a branch box unit, your outdoor unit has to be addressed. Your indoor unit branch box has to be addressed. And on the branch box, you have to turn on each port that you're using. So if you've got a 5-port branch box, number 6 is not used, but 5 ports are. And if you're only using 4 ports, you're going to throw on 1, 2, 3, 4, and you're going to leave this one off. And then you have to set these addresses. The outdoor unit is usually addressed between 51 and 100, and the indoor branch box between 1 and 50. If you look at the installation instructions, it's going to tell you to address the outdoor unit at 51 and the branch box for number 1. That gets a little confusing because sometimes the branch box is upside down, sometimes it's on the side. The outdoor unit is labeled switch 1 is here, switch 2 is here. So if digit number 1 is here and digit number 2 is here and they say set for 51, do you set 5-1 or 1-5? That's confusing. So what we always tell people to do is it can be anywhere between 51 and 100. Set this at 5-5, set this at 11. And if you have 2 branch boxes, set the second one at 12. Makes it very, very simple. So they're telling you to set the branch box for 50, or the outdoor unit for 51, the branch box for 1. The indoor units configure themselves as 1, 2, 3. The other branch box would be set for like 4, or if there's a 3 zone and a 5 zone, this would be set for 4 and it would go 4, 5, and 6. You don't have to do these settings here. This will do automatically, but you do have to set the address on the outdoor unit and on the branch box. Okay, we're going to go system startup here real quick. Some things to look at, good practices, make sure your refrigerant pipe work is good, correct refrigerant trim charge if you have to. Make sure that addresses are correct. If you need to set an address like on the branch box unit or possibly on a P series where you're using multiple units off of one control, you would set an address. And make sure all the dip switch settings and all are proper. You check your voltages, make sure you got the proper supply and that the condensate drain is in good shape. Make sure that you can get to everything for a periodic look at the system, make sure the coils are clean and so forth, and make sure that you can get to it and clean the coils. And then I want to talk just briefly about the warranty. A standard warranty out of the box, if you install it and don't register the warranty, they will get 5-year parts, 7-year warranty from the date of manufacture. If you register the equipment online, you go online and register it for your customer, they will get a 10-year parts and 10-year compressor warranty. Must be, on the M series, must be installed in a single family home, applies to the original owner, and must be registered by you within 90 days. If you're a diamond contractor, if you are, you probably know you are. If you're not want to be, you have to come to the 2-day training, hands-on training in Plymouth, Minnesota, or out in our Utah facility, and hopefully soon to be in our West Dallas facility down by Milwaukee. Go to one of those facilities, you have to attend the class for a full 2 days and take part in hands-on training and so on and so forth, and sign some documents and guarantee that you're going to sell a certain amount of equipment a year, and then you become a diamond contractor. And then you have to be recertified every couple of years. But if you're a diamond contractor, then you get a 12-year parts and 12-year compressor warranty for your customer. Again, if it's registered within 90 days and it's a single-family home and lived in by the owner. P-Series, basically the exact same thing, 10-year parts and labor warranty. You can get a 12-year parts and compressor warranty if you are installing a P-Series in a single-family home. If not, it's just a 10-year warranty. We do sell a third-party warranty, a service agreement. If you did want to include labor, there is a labor warranty that's available for you to sell. It's a 5, 10, or 12-year for diamond contractors, 12-year labor warranty. It's kind of neat. It gives you a little markup on the parts as well, so that if anything does fail within, say it's a 5-year warranty, normally Mitsubishi would just give you the part and you have to charge the customer the labor, and you don't make anything on the part. But if you have one of these warranties, you do get a parts markup, plus you get the labor that you agreed to. There's different labor contracts, whether you want, in this case, $75 or $100 an hour labor, and I think there's a couple other options. It's really more of a sales function, but I thought I'd mention it because it is available if you're interested, and it's available on light commercial or residential. And I mentioned you had to register the warranty. You just go to www.registermehvac, that's ME stands for Mitsubishi Electric HVAC.com. You go there and click on installing, register here. If you're a homeowner and register here, you're not going to get the 10-year warranty. It's just going to register you for the 5-year. So make sure you, as a contractor, go in and fill out all the proper information. You can register at that website. Somebody at your office can do that. Or if you have this app, which you can download from MyLink Drive or the App Store. It's mentioned on MyLink Drive with instructions, but from your app store, you can download this. It's got a QR reader that you can zap the indoor, outdoor units. It knows your geographical location. And when you first install the app, you put in all your company information. All you have to do after you take a picture of these QR codes on the equipment is put in a homeowner's name and email address, and the systems are registered instantly, and your homeowner will get an email immediately showing what their warranty is. So it's kind of a neat deal. Also, you can go back here and just do a warranty lookup. So if it was ever registered and you click on it, it'll come back and tell you what the warranty is on that unit. So it's kind of nice. If you're not sure if it's in warranty or not, you snap a picture of that QR code, look at your reader, and it'll tell you if there's any warranty left on it or not. And they may say I had a 12-year warranty, but hang on. I didn't want to do that. There we go. They say you have a 12-year warranty, but the homeowner might say that. But if it was never registered, they got a 5-year warranty. So it's kind of nice to know that. Okay, real quick, we'll talk about operation, then we'll go to another break. The indoor units, if they start with a letter M, will come with one of these remote controls. If they don't start with a letter M, you have to put one of these type controls on it we talked about earlier. This is either a par 33 or soon to be par 40. Looks like this. Neat control. You can do some diagnostics with this control and look at, compressor speed, thermistor temperatures, just a number of things. Your linear expansion valve, how far open or closed it is. This is a unit that's got a sensor that can detect if there's people present or not and put it in and out of setback mode. This is the simple MA. This is the one we sell the most. It's the PAC YT53. It's very simple because these are all just 2-wire controls. This just is the temperature up and down. You've got the mode, you've got the fan and vane, and that's it. So it's very simple. This is basically the same as this, only it's a touch version. It's a touch screen that lights up, and kind of neat because you can upload your company logo to the stat if you wanted to. And then over here, this is the old MHK1 that is being replaced by this MHK2, which Mitsubishi is just about out of these now, and once they're out, they will start to ship this one. And once we're out, we will start to ship this one. So it's this MHK2 will replace this. This is a red link type controller that's wireless. There's a little receiver that mounts up at the indoor unit, and this mounts on the wall. This is the Kumo Cloud, which allows you to do control your indoor equipment through an app. Kind of neat, easy, somewhat easy to set up. It does require a 2.4 gigahertz Wi-Fi network. Can't be used with the 2.4 and 5 mesh network. There's a lot of those out there now, so you got to be very careful. If they have this and they want to add all these to their indoor heads, they're going to have to buy a new Wi-Fi router that's 2.4 gigahertz. They're very inexpensive for a little router. Just make it a dedicated router if you're going to use this. Pretty easy to set up here. Let me move me out of the way here. This is what the new thermostat is going to look like. This is what the new receiver is going to look like that mounts up at the indoor unit. It plugs in here to the CN105 connector. You can also plug in here a Kumo Cloud, so then this combination makes this a Wi-Fi stat as well. So it's kind of neat, kind of unique. Be aware of it. There's a Kumo station available. This is basically a little relay panel that you can put an outdoor air temperature sensor on and do if this then that type control here. You can say that these are 4 relays in there. You can say, for instance, that through the Kumo Cloud app, you can say that if the temperature is below 0 degrees, then I want to allow my boiler to come on, or I want to allow my humidifier to come on. If you sell the Kumo Cloud with the little humidity sensor, you can control the humidity with one of these relays. Maybe turn your condensing unit off with one and turn a boiler on with one. Just a kind of a unique thing that you can use. It's a bunch of 4 sets of dry contacts that you can use, and they're single pole, double throw type contacts in here. So you can use them for a number of things. There's little switches. You can manually turn those relays on if you wanted to, or let them control how you have it set up. This is the thermostat interface we talked about earlier about. It does require this little transformer, and you're able to control our equipment through the CN105 by wiring a thermostat to here. You need a Y1, Y2, W1, W2, G wire. You have a common and a hot lead from the thermostat, and a common and a hot lead from your transformer. This Procon unit is a backnet interface that also plugs into the CN105. So if you have a commercial job with backnet controls, we can use this to control that system. Now we have almost to the end of this section. We'll talk a little bit about emergency operation and test run. If you put it in test run by pushing the little button, which is the hang on, let me find out. EO switch. There's an EO switch on the front of these units. Sometimes it's inside, but there's always an EO type switch that you can usually find someplace. If there's an EO switch, you push it once and you put it in cooling test mode, and it'll run that way for 30 minutes in test mode, so you can do your testing, your compressor, and everything runs at one speed. If you press it twice, it'll put it in heating test mode for 30 minutes, and you push it 3 times, it stops. The interesting thing is it will not stop unless you tell it to stop. If you put it in emergency cooling mode, it will stay at 75 degrees until somebody takes it out of cooling mode. And that's neat, because if somebody loses the remote control or their batteries get dead or whatever and they want to turn the equipment on, just push the emergency operation switch once, and that unit will control to 75 degrees off the return air temperature, and hopefully make a somewhat happy customer for some period of time. The little LEDs that light up in here do mean something. There's 2 sets. If they're both lit, it means that you just turned the equipment on and it's more than 4 degrees off a set point. As it gets closer to set point, one of the lights will shut off, and so it's between 2 and 4 degrees, only one light's lit. And then if one light's lit and the other one has got a steady flash, then you're in normal standby operation. These are the same lights down here, that same light that will give you an error code when we get into the test mode. Okay, that's it. We're going to stop right now, and we will do functional overview later. So we're going to stop sharing, and I will be back later. Hopefully you will join me. Thank you for listening.